Welcome to the Ghost Geeks. I'm Chad, and today we bring you the third part in our three-part series on EMF and K2 meters. And now for the Geek Dive. In this final video on EMF and K2 meters, we are going to discuss EMF wave movements so we can better understand how they interact with our surroundings. Then we're going to discuss some of the laws that govern electrical charges, waves, and electromagnetic fields. And lastly, we are going to discuss something that may completely change the way you think about reflections. Trust me, this new theory might blow your mind. In the very first video, I talked very briefly on how electromagnetic waves can be thought of, in the simplest terms, as movements of particles in relation to their charges and the way those charges react or interact with other charged particles. I also mentioned that charged particles will wobble when opposing charges come near, and that this wobbling generates electromagnetic waves. Let's dive into some of the properties of waves and how they provide support for many paranormal theories and phenomena. First, electromagnetic waves are either polar or nonpolar. Nonpolar waves produce a random pattern. This pattern propagates outward and affects other particles to also vibrate in the same random way. This is how the sun heats the Earth. It sends the waves through the vacuum of space to hit the Earth. Polarized wave movements move in one of three patterns: elliptical, circular, or rectilinear. Radio antennae excite atoms in a rectilinear motion to produce waves. The power of the station determines how far the waves will go, and the frequency used to excite the atoms determines the station you tune your radio to receive the source. Polarizing filters are what allow 3D movies to work. The lenses filter the direction of the visible light, so only one direction can pass through the filter, allowing each eye to receive two different frames at the same time. Electromagnetic waves can be measured from the point in which they are created. This measurement is called the flux. On a side note, this is where the idea and the term for the flux capacitor came from. Anyway, the flux can be measured by taking the point charge divided by 4 pi times r squared. This is the base to determine the strength or force of the electromagnetic field using the formula F, or force, equals K, Coulomb's law, times the product of the two charges, Q1 times Q2, divided by the distance between them squared, r squared. This formula is also known as Coulomb's law. Electromagnetic waves, like all waves, behave in very specific manners. For example, waves will add on to each other. If we superimpose two identical crests, they will result in a crest twice as high. If we do the same with a wave with the opposite crests, then they will cancel each other out. This is known as interference. One interesting side effect of interference is that when light waves propagate together and exceed the speed of light, then much like an aircraft exceeding the speed of sound will produce a sonic boom, the new propagated light wave will actually produce a flash. This effect is known as the Cherenkov effect. It is used by particle physicists to detect neutrinos. But to us paranormal investigators, there could be some use of this effect to describe orbs or mysterious lights. Here is a clip of what I believe is an example of this effect captured at an investigation. Watch carefully because it happens fast.
Oh, there was just an orb on the chair.
We can also take advantage of interference and conductive metals to use Faraday's law to block unwanted waves. You may know of the device of his namesake called a Faraday cage. Let's show an example of this with a simple homemade Faraday cage and then look at how it actually works. I'm going to build a quick box with aluminum foil layers. Now that I have the box, I'm going to take this SB7 spirit box and tune into a local radio station here. Now I will put the radio in the Faraday box, and it should block the radio waves from reaching the spirit box antenna.
Frequency mode.
So I bet the first thing you thought was, it won't work because it has holes in it. Well, that's technically true. Waves smaller than the holes will enter the Faraday cage and potentially interfere with or be picked up by whatever device we have in the cage. So how do we know how small the holes have to be, you ask? Well, this is a simple equation of lambda equaling the speed of light divided by the frequency. This works great if you know the frequency of the waves you're trying to block. And for us, it's usually radio waves, since they carry unwanted audio signals. So, the speed of light can be represented by either 3 times 10 to the 8th meters per second, or 299,792,458 meters per second. This means that the radio station of 1021.1 megahertz looks like this. Lambda equals 299,792,458 meters per second divided by 102,100,000 cycles per second, which equals 2.94 meters per cycle. And that's a pretty big wave, which is why the holes in my little experimental Faraday cage can still work. Now, visible light is also electromagnetic waves, but they are much smaller and therefore can still enter the box and interfere or be received by any device in the box. So we would need to reduce the hole size if we were targeting visible light as to limit the waves entering for filtering. Now, I want to end with this as I present an interesting theory on electromagnetic waves and reflections in mirrors. Now, mirrors have long-standing legends attached to them, and they're often used in religious ceremonies and other types of metaphysical practices. Many believe that mirrors are portals, but I have a different take on them altogether. And my theory is rooted in the properties of electromagnetic waves and the conductive properties of metals. First, let's take a look at the build materials in ancient, old, and modern mirrors. The very first ancient mirrors were made of obsidian rock polished to a mirror-like finish. These were obviously obscenely heavy and very small, so they were only made for kings and religious usage. The next stage of mirrors were simply metals polished to a superfine finish. This was a time and labor expensive process, mostly because the best metals for the job were silver, gold, or bronze. Then came glass and industrial processes that allowed us to electroplate or coat these materials to a surface. And in the 1400s, the Venetians used an alloy of tin and mercury to do just that, which, by the way, they made top secret and wouldn't share with the rest of the world. The only problem with this process is the mercury, which is toxic. So about 150 years later, the mercury was replaced with silver, and the rest of the world finally figured out how the Venetians were doing it. This allowed us to use significantly less of these precious and expensive metals to create mirrors. Today's mirrors use an aluminum backing to create the mirror surface. But the one thing all these mirrors, minus the obsidian mirror, have in common are they are made of conductive metals. Conductive metals obtain their ability to transfer charges because of the outside of the metal having free electrons that can move independently of the metal itself. When we look at an electromagnetic wave traveling to the metal surface, we can see that the wave striking the metal will cause those free electrons to be set in motion, creating electrical currents on the surface of the metal. These currents perfectly reproduce the shape of the incident wave. The movements of the electrons on the surface will generate a wave similar to the incident wave, but will propagate on both sides of the surface. This new wave corresponds to the reflected wave. When we look at ourselves in a mirror, it is this wave, generated by the electrical currents that we see. In other words, the free electrons in the mirror generate electricity that then propagate outward from the metal to create the reflection, not the original light wave itself. What I hypothesize is that spirits are able to excite the free electrons in the mirror's metal coating using their electromagnetic fields, and thus create a reflection of themselves in the mirror without them having first be visible. This would create the effect of seeing something in the mirror and turning to see nothing. The spirit did not need to be physically manifested to create a reflection. This theory makes a lot of sense when you think about things like psychomantiums or other seeing techniques that utilize a mirror. Spirits may be able to manifest themselves in mirrors far easier than the energy required to become a full-bodied apparition. This theory has significant evidence of probability, since this is exactly how old cathode ray tube televisions worked. In those, an electron stream is used to excite the electrons on the other side of an aluminum-lined cathode ray tube, and that electron stream is controlled by two magnetic fields, one for propagating the electrons down the scan and the other horizontally, with the brightness being controlled by the power of the electron pulse. The end result is a single dot moving through the entire screen of a TV 50 times a second, generating the picture we see. And if you think about my theory in the context of the Poltergeist movie, it makes it way creepier in my opinion. I hope you've enjoyed this series on EMF and K2 meters. And as always, please like and subscribe to help us keep more content like this coming your way. And until next time, I'm Chad with the Ghost Geeks, and remember, talk nerdy to me.